Hello everyone, this is Srinidhi from Sri Venkateshwara College of Engineering from Department of ISC from class Eacher. Now I'm talking about storage classes in C program. Now let us know about is storage classes. Importance of storage classes. Storage classes play a significant role in variable scope and lifetime. They help in managing memory, allocation and deallocation effectively. Familiarity with storage classes aids in preventing memory leaks and undefined behavior. Types of storage classes are there are primarily for four types of storage classes in C and C++. They include automatic, static, external and register storage classes. Each type of unique characteristics in terms of visibility and lifetime. Now let us know the first type, automatic storage class. Automatic storage class is a default storage class for local variables. Variables declared within a function or block are automatically allocated and deallocated. The scope of automatic variables is very limited to the blocks in the which they are defined. The characteristics of the automatic storage classes are automatic variables are created when the block is entered and destroyed upon exit. They are stored in the stack memory, which allows for a quick access. Automatic variables are not initialized by default, potentially leading to garbage values. We can see the picture over here. Write a C program showing the below terms for automatic. And the other type of C is static storage class. Static storage class maintains the variable's value between function calls. Variable declared with the static keyword have a lifetime equal to program's execution. Their scope is limited to the block where they are defined, but they retain their values. And the characteristics of the storage classes are storage variables are initialized only at the start of the program execution. They are stored in the data segments of the memory, not on the stack. We can see the example over here in the picture. Static storage classes is very useful for preserving state information across function call. And the other type of the storage class is external storage class. External storage class allows variables to be accessible across multiple files. Variables declared outside of any function are considered to have external linkage. They exist for the lifetime of the program and retain their value throughout. We can see the example over here. That is which is student 1 case and student 2 case of storage class. And the characteristics of the external storage classes are external variables are initialized to 0 by default if not explicitly initialized. They can lead to potential naming conflicts if not managed correctly. External variables are stored in the data segment similar to static variables, and we can see the example over here in the picture. And the other type is register storage classes. Register storage classes suggest that the compiler store the variables in the CPU register. This can enhance the performance by allowing faster access to frequently used variables. However, the number of registers is limited, so not all variables can be stored this way. And the characteristics of the storage classes are register variables cannot be accessed via pointers as they may not have a memory address. The lifetime is the same as automatic variables, but they are stored differently. The use of register storage classes should be judicious to avoid resource constraints. And the comparison of the storage classes can be compared based on scope, lifetime and storage location. Automatic, the register classes are local in scope while static and external are not. Understanding the different helps in the selecting the appropriate class for variables, and you can see the table over and you can refer it. For example, scope of storage classes. The scope of variable determines where it can be accessed in the program. Local variables are only accessible within their defined blocks. Global variables can be accessed for any part of the program, enhancing flexibility. And the lifetime of storage classes. The lifetime of a variable refers to duration it remains in memory. Automatic variables exist only during function execution, while static and external variables persist. Proper management of variable lifetime is essential for resource optimization, and you can see the table over here which is helpful for lifetime storage classes. And the memory allocation in storage classes. Memory allocation refers to how and where variables are stored in memory. Automatic variables are allocated on the stack, while static and external variables are on the heap. Register variables are located in CPU registers, offering the fastest access times. And the best practices of using storage classes. Choose the appropriate storage class based on variable usage and requirement. Minimize the use of global variables to avoid naming conflicts and unexpected behavior. Always initialize variables to prevent errors during garbage values. And the common mistakes in the storage classes are failing to understand variable scope can lead to unintended access and modifications. Overusing global variables can create dependence that complicate program maintenance. Neglecting to initialize variable can cause unpredictable behavior during execution, and you can see the errors and the mistakes which we make in the storage classes part. The picture over there. The conclusion of the storage classes. Understanding storage classes is a vital for effective memory management in programming. Properly utilizing storage class can enhance performance and reduce errors. Continuous learning and practice can help developers master storage classes concepts. And the reference you can use for storage C programming in storage classes are the over which is referred here. You can use this. Thank you. Please like, share and subscribe to my channel.